Okay guys, this is Amir, an AI student. In this video I want to review the linear regression with usually Python, and here as you can see I'm using the Neuromatch tutorials. You can access them by searching Neuromatch Academy Tutorial Materials, and actually I am using the W1D3T1 tutorial 1. Yeah. Okay, so I copied that in my Google Drive. Here we want to review this tutorial about how to fit a line to the data, which we call that linear regression. Okay, so consider we have gathered some data here in the x-axis. For example, it is the, let's say, the grade, and in the y-axis, let's say we have the happiness. I don't know, maybe it is not a good example, but anyway, it is not important for us. The important thing for us is how to fit a line through the data. And we collect a bunch of data, and they're all like this. The better grade you have, the more happy you are, and the lower the grade you have, the less happy you are. Which of point are about me? Yeah, I am in this line, like, yeah. But anyway, after 1 week or some months, I forget about my grades. Okay, we want to comprise and compress our data and explain these bunch of points with just a simple line like this. Okay, we know the equation of line. We can tell y equals theta, for example, times x plus I don't know, plus I. I is intercept, and theta is slope. Our y in our example is happiness, and x is grade. Okay, you're probably familiar with this notation. Y equals ax times b, which is the same. They are exactly the same. Okay, so the problem here is we don't know, okay, what we have these values. Of course, we have the x, which are grades, and also we have the y, how happy our student is, but we do not know the slope, we do not know the intercept. For simplicity, let's ignore the intercept right now, okay? We do not consider intercept right now, and make our equation more simple by just simply say y equals theta times x. So we know y, we know x, but we don't know about anything about theta. First, we can actually try and error. We can try a bunch of different thetas, from, for example, -10 to, I don't know, 10, and see which theta fits the visually, which theta fits the lines better. For example, with theta -10, our line should be something like, I don't know, this. And with theta +10, maybe our line should be something like this. And somewhere between, we see that some theta is good, visually, without any equation and direct solution. But we are going to find an exact solution by coding, by mathematics in this tutorial. Okay, let's go through the tutorial. Okay, here we see again the equation, and here is the concept of MSE, or mean squared error. Okay, what is MSE? To directly and mathematically find the best theta, we can use mean square error, which stands for MSE. Okay, here we have mean. Mean is something like sigma over n. Sigma of something over n. A square is when you multiply it by itself, or to the power of 2. This is a square. This is mean, and the error, this is error. What does error mean? Error means the how far we are from the true value, from the exact value, right? Okay, we can say that error is true value minus predicted value. And actually, MSE wants to give us a measure on how our line is good or not. Okay, for example, let's go to the upper, here. For example, with this line, we want to have a low MSE. Our MSE right here, maybe, I don't know, number 2. Why? Because MSE tells us is a measurement, is a tool for saying us how our line is good or not. Okay, so right here, MSE might be number 2, and for this line, which is a very bad line fitted to our data, MSE, I don't know, might be number, I don't know, 200. A very bad line. So we want to mathematically find the best MSE, the lowest MSE possible. Okay, let's go through the tutorial again. Okay, you can see the Mse equation here. 1 divided by n times sum of true values minus predicted values to the power of 2. This is MSE. And this is the error term, right? So you may ask, what is this one? And I can tell you, let me delete this. And I can tell you, okay, uh, 1 divided by n times sigma true value. Of course, I start from 1 to the n to the last point, minus predicted value to the power of 2. As you can see, error is true value minus predicted value. Okay, so we can rewrite that as we know the predicted value was this one, right? We say our y, our predicted y, is theta, which is slope, times x. And right now we ignore the intercept. So we can write down as yi minus theta times x to the power of 2. oops, sorry, I must select all of that. Stupid AI. Okay, I want to move it. Okay, I select it. Oh, this way. And now I want to copy this part. Copy. And paste it here. Maybe I should simply press, oh yeah. Simply press Ctrl V. Okay, let's move it a little bit to the right. Okay, and I can actually, I think if I write it again, it would be easier. No. Yeah, finally I do it. Okay, so this is the exact equation we find in the tutorials. And as I told you, we want to minimize this Mse value. Okay, here they generated some random data with this code. For example, in line 7, they froze their random numbers. Then they choose theta 1.2. Remember this value. This is the true slope. I want 30 points. The x values are random numbers between 1 and 10, 0 and 10, and they generated some noise. As you can see, they are not exactly in a line. They have some noises added. And then they simply generate y in this way, theta times x plus noise. And they plot it, x, y. Okay. Here, we wrote a function which gets x and y and theta hat and say what is the Mse of this equation. Remember? Here we generated different lines. This is x, this is y, and of course our theta, which is not good, it was -10, right? Okay, so we pass the x, y, -10 here, and they compute the Mse. np.mean of error squared. Mse mean squared error. And they generate predicted y as theta hat times x. And then they try their function with some numbers, and they calculate some Mse for that. And they found the theta hat of 1 has the lowest Mse. And this is the figure of that. With theta hat 0.75, theta hat equals 1, theta hat equals 1.5. Here, they generate a really good widget. With a slide bar, we can try many different theta hats and visually see which one is better, right? If I choose very large theta hat, okay, it is not connected, sorry. If I say reconnect, they are not connected because I am not connected to internet. Anyway, but if you put, for example, a large number, it will be something like this line, for example, and it will give you a large Mse. And as I told you, go to this link, tutorial 1, and run it by yourself. And if you choose a very low theta hat, for example 0, it will give you also a large Mse for that. And here they have a very nice figure. They tried very different theta hats. For example, they say, okay, let's say theta hat is equal to -2, theta hat is equal to 4, and they calculate Mse for that, and they plotted this figure, and they found somewhere some number around 1, between 1 and 1.5. They have the lowest Mse possible. Okay, this is the first step. In this step, we learn a tool which is called mean square error, which gives us a measurable and in a mathematic way to find the lowest minimum squared error, the lowest error possible. We generated different lines with different slopes and find the lowest Mse. But you may ask, should I in reality, for example, generate different lines, for example, between -100 to 100 and plot this figure, and again usually find, for example, the best value of theta hat or not? And I say no, there is a solution for that. And in this section we want to again find the best, the least Mse possible, which is called least square optimization. As you may know, and as you see here, we want to find the lowest Mse possible. So how can we do that? Actually, we can do that by, if you go to the balance section, they explain you can find the derivative of this function according to theta, right? Okay, so I want to minimize this Mse function, this cost function. It is like cost function, right? We want to minimize the cost. We want to minimize the error. We want to minimize the error relative to theta. So, if you know how to do derivation, you will understand this. 2 goes to the behind the parentheses, and it will become -2, possibly because this is negative, and they solve for theta, and they come to this equation after solving for theta, and in vector notation we can write this as this: the best theta possible, which gives us the minimum squared error, is x transpose times y divided x transpose times x. It's not too hard, right? Okay, so we can create a function, for example, the solve normal equation, and we pass the x values and the y values, and as we know, theta hat is x transpose times y divided by x transpose times x, and this at sign notation is matrix notation for multiplying. And this function tells us the best theta I found is 1.21 with the Mse of 1.43. So the lowest value is 1.21. And they finally plot it again. So, as a summary, we have 2 sections. At the first section, we find a measure to find the lowest Mse value, and in this second section we learn the tool to automatically optimize for the best or the lowest cost possible, lowest error possible, and which is least square optimization. That's it. Have a good day and see you in another video.